fast. Doctor, how is my life these days?
I think it's okay.
So can you start with question 6, guys, please?
So many numbers that then you have to do something.
Yeah, like over and over. Then you have to draw the thing. I don't bother, but I think at some point I just
At some point you like miss one number and then this is everything. Like if you and you notice that the number iron then you have
by this
to add up 20
I think at some point you just use it. You just like do sum everything.
Can you guys do question 6, please? Shh. Questions number 6. Can you do this, please, first?
For me, I'm trying to think. What's it? Justification is number 4. Number 4 is the one that you start.
No, I don't. I can't do much for you.
I'm just trying to figure.
I will not strike that.
It's more like
You're right. Careful. You're okay. Everything okay with you?
Yeah.
How's the other process going? Any number going okay?
I didn't have your first.
How you doing? Are you sir? You're right.
fine. So if we have like any questions, please ask.
So the answers for this we should find when the notes for week. When last week were.
The answers are online on the post website.
There are
Answers for all the example classes are online on the post website.
The notes for the answers.
no, just in general, they're on this website.
Have you guys done question number 6, guys? Let me know if you've done it. Then I will show you how to do it on the Go on. How are you, sir? You okay? Yeah. Good, good. You guys okay? guys, can you listen to me, guys? Can you hear me what I'm saying? Right. Let me show you how to do question 6, right? If you haven't done it already. So I'm going to sit down for a while. So question 6, part 1. Question 6, part 1. You have a variable x that has a normal distribution with parameters. I mean, I talked about the normal distribution. Was it this week or last week? I can't remember. I talked about this, okay? Now, one of the properties of the normal distribution is that x do you remember this property I mentioned in the class? Hello guys, do you remember this? Yes. Okay. So this implies that the CDF of x, which is the probability that x is less than or equal to x, which is this, right? Now we know that this guy here has the standard normal distribution n0, 1. Okay. Now this we can write as phi, because phi denotes the CDF of the standard normal distribution, right? At x minus mu divided by sigma, where right? Okay, so it's easy peasy, right? It's not difficult, is it, guys? So this is what you're asked to prove. You're asked to show that the CDF of x is equal to this, right? So we are done. We're done part 1. Any questions on this, guys? Now part 2 is this guy here. You should look at part 2 of the question. I don't know whether you can read this. All right. Part 2 is this. Is to show that the quantile function for the normal is given by this formula here. I'm gonna do that now. So I'm gonna show you how to do part 2 of question 6. Okay, Q of P, which is known as the quantile function, right, is defined by the following statement. It's defined by this statement, that the probability that x is less than or equal to q at p is equal to p. Now this is the same as, because we proved that this guy is this, right?
Also, so you can just like rearrange it to that.
Yeah.
You make it so that QP is isolated.
Yeah. That's what I'm going to show you now. Now this fx at q of p is this what we derived in part 1. Okay, this is by part 1. Do you follow me? Okay, so far. Right, now what I'm going to do is I'm going to rearrange it so that I get the expression for Q of P. So the first thing I'm going to do is to take this to the right hand side, so that becomes like this, yeah. And then you rearrange this to get the final answer, which is Q of P equal to mu plus sigma times find us p. Alright, so this is what you were asked to prove. You were asked to prove that the quantile function for the normal distribution is equal to this. And we have proved that. Okay? Any questions so far, guys? Hello guys, talk to me, please. Why don't you guys Zoom me anymore? I mean, I keep all my Zoom 24/7, and you never Zoom me. Why? Huh? You have no questions or what? All right. Now, the question is also asking about IQR. Remember IQR? Do you know what IQR is? The interquartile range, right? You remember that? I talked about it in the class. The interquartile range is the difference between the third quartile and the first quartile. So the first quartile or quantile is the same thing. The first quartile or quantile do you remember the definition of first quartile? How do we define it? Oh, come on, guys. What's the definition of first quartile?
P over X.
Exactly. It's Q at 0.25. Yeah? So if you put 0.25 into this formula here, you get mu plus sigma right? That's what you get. All right? That's the first quartile. Now, the definition of the third quartile is Q at 0.75, which is mu plus sigma times phi inverse at 0.75. You follow me? All right. Now, the IQR, or interquartile range, IQR is the difference between the third quartile and the first quartile. So it's the difference between this guy here and this guy here. So if you do that, you get sigma times phi at minus 0.75 minus phi 0.25. Okay, now you remember the normal table. You can read these two guys from the normal table, which I showed you last week or this week. I can't remember. So anyway, you should read these two guys. You get the value. You will get the value 1.349 times sigma. So that's the. So that completes question 6, right? And part 3, you can ignore part 3 of question 6 because we haven't done question 5. So, any questions on this, guys? Are you okay? Anybody has any questions on what I've done? Feel free. You okay? Yeah. Anybody? Campbell, you okay? Okay. All right, can you do question 2 now, please? Question 2. So I'll take this away. I will take this away and ask you to do question. Can you guys do question 2, please? I'll give you a few minutes.
It's Q1 fourths. Q1 tenths, Q1 fourths. Q3 fourths and Q. Oh wait, no, never mind. It's lowest 25 million. So if I your academic advisor?
Just completed algebra.
Minimum quartile, median, third quartile, maximum. You need to compute each of them
Yours is who?
for the data that you're given.
It's Professor Sergey Fedotov. This is Professor Fedotov.
Anybody else who hasn't signed the acronym sheet? You get a call from your parents if you don't. Yes.
It's the one that's currently doing like real research on like.
It's from the normal text. Remember the data that they give. Yeah. So if you look for 0.75, you need to look for 0.75. Not over here. It's on the inside the text.
This sets one. This is like standard, like the sample with the standard deviation is like, you need the computer for this. I think.
So you read it like that. Similarly for 0.25, you need to look for 0.25. Yeah. It's minus. Minus to
I think this is what you do.
I'd rather do that than just. I'd rather do that than just.
remember, because it's metric, you have a pen. Can I use a pen? Yeah. It's two times the volume of 0.7. Minus plus. So here I have Q naught. What Q and I people are confused.
Do we use like the one like for the quartile calculation? Do we use the one that you gave us?
What do you mean?
Like x,
Yeah.
r prime.
Yeah. That's the one you use. Yeah.
So is it type 6?
Yeah. I'll show you in a minute. Just give me a sec. Hello, guys. Could you listen, please? Q2 for part 1. The 5-number summary. The 5-number summary is this: the minimum, the first quartile, the median, the third quartile, and the maximum. All right. So the minimum. What is the minimum data point, guys? Yeah, I have it here. It's 30. The minimum data point is 29.14. Is that right? Okay. The next one is the first quartile, which is this guy here. So I'm going to use the formula that you guys used in your quiz 3. I mean, you all done quiz 3, right? Yeah. So P is what? P is a quarter, and your N is 20. So your R is P times N plus 1, which will be what? Which will be 5.25, I think. Okay, so, and your R prime is the integer part of this, which is 5. Okay, so Q at 0.25 will be X sub 5 in brackets, 5.25 minus 5, then in brackets X 6 minus X5. By the way, guys, this is not, it shouldn't be square brackets. If I done it, I don't know. It shouldn't be, this is round bracket, not square brackets. Okay, guys, you follow me? This is round bracket, not square bracket. I mean, it's a normal bracket, without. Okay, so if you do this, you get 37.03225. That's the answer you get for first quartile, all right? And for the median you have a simpler formula because n is 20, which is an even number. Do you remember the formula I gave you for the median? Is half times x. So this is once again curly brackets. X n over 2 plus x. Do you remember this formula? I gave this in the notes, in the handwritten notes, right? So this will be half of n over 2 is what, 10, yeah? And this is is it the correct formula? Is it the correct formula I gave in the notes? Can you check somebody? Can somebody say check this? It's n over 2. Oh, no. N over 2 plus, oh yeah, I made a mistake. Shit. This is not the correct formula, guys.
No, it's x n over 2 plus x n over 2 plus 1.
Yeah, I know. I just realized. You should have corrected me, guys. All right. Is x n over 2 plus 1 outside? I mean, outside the fraction, like this. Okay. Like this. Sorry about my messy writing. So this would be x11. Okay, this is, and if you work this out, you get 41.186. Right, that's the median. Right, and next one is the third quartile. Right, so your P is 0.75, your N is 20, so your R is P times N plus 1, which will be 15.75. Okay, and your R prime is 15, so Q at 0.75 will be 15. Okay, like this. Alright, and if you work this out, you will get 44.01975. Okay, so this is the third quartile. And finally, the maximum value of the data, or the largest data point, is 51.261. Alright, so is this clear, guys? Any questions on part 1? Anybody has a question on part 1? Yes, no? Okay. Alright, so that's part 1 we are done. Part 2 is to calculate the sample mean and the sample standard deviation. Right? So the sample mean is, it just simply, you sum up all the data values 1 to 20 and divide by 20, right? That gives you the sample mean, right? So that will be 40.6942. Okay, and the sample variance, remember the sample standard deviation is just simply the square root of the sample variance. I'm gonna use the remember I gave you two formulas for sample variance. There's a biased version and an unbiased version. Alright, I'm going to use the unbiased version, which is n minus 1 here, instead of n. You remember that? Yeah? So I'm going to use the unbiased version.
Does the unbiased version have something to do with continuity correction in some way, right?
Yeah, but I don't think it's to do with continuity correction. But anyway, in this case, I'm using the unbiased version. Right? This is the unbiased. Right? And if you use this formula, guys, after some calculations, you will get the number 30.54. Right? This is the sample variance. So finally, the sample SD. SD is the standard deviation, will be just the square root of this guy here, right? So it's 30 square root of, okay? You follow me? Any questions, guys? So this, if you do this, you get 5.527. You okay so far? All right. All right, now that's part 2. We are done with part 2. Part 3. Part 3 is asking you for a table. I mean, you must have done things like that. You must have done things like this in your A level. So you have basically 3 columns of data, 3 columns. The first column gives you the intervals from 25 to 30, right, in lengths of 5. So it's going to be like this. It's going to be 25 to 30. 30 is an open interval, right? Then 30 to 35. Then 35 to 40, then 40 to 45. Okay, and then 45 to 50, and finally 50 to 55. Okay, like this. Right, and then you just, all you need to do is just count. So in each of these intervals, you need to count how many data fall. I mean, anybody can do that, right? So for this interval, you have 1 data point. For this interval, you have 2. For this interval, there are 5 data points. For this interval, there are 8 data points, and 3 and 1. Okay? Are you guys okay? And the density is simply the frequency divided by the total number. So you divide 1 by the total number, which is what? What's the total number of data points? 20. So you divide by 20, 2 by 20, 5 by 20, 8 by 20, 3 by 20, and 1 by 20. Right, that's it. It's not difficult, is it, guys? Okay, now the next part, the final part of question 2. Part 4. Part 4 of question 2 is asking you to draw the histogram. The histogram is just basically this versus this. So you plot, what you do is you plot the interval column, sorry, the density column versus the interval column. That will produce what is known as the histogram, right? And I'm lazy to plot, so I'm going to show you the graph. So I'm just going to show you the graph. It looks like this. Well, you should do that. You should plot the density column versus the interval column. You will get something looking like this, right? And do you see what's the shape of this, guys? Is it symmetric or skewed? Come on, guys. It's approximately symmetric, right? So you say that the distribution completes question 2. Now, can you do question 7, please? 7. Unless you have questions for me. This is question 7 is this one. It should be easy for you. similar to quiz 3. You did quiz 3, right, all of you? Yeah, this is very similar to quiz 3. Yeah, so let me do it quickly because I'm running out of time now. I didn't realize.
Wait, gotta keep them on the second. Like 7. You basically, you know the sample meaning equation is Q. Is what? You know how to do it.
Guys, could you listen to me, please? Hello? Your P is half. So your R is what? R is going to be n plus 1 divided by 2. Right? And your R prime now, what can you tell me what R prime is? Because if n is odd, n plus 1 is what? N plus 1 will be even, right? So even divided by 2 is what? It's an integer. Alright, so this will be n plus 1 divided by 2. You follow me? Yeah? So Q at half will be x n plus 1 plus r minus r prime, which is this.
And that's 0.
That's 0, so you can ignore the rest. Alright? So this would be x n plus 1 divided by 2. Now let's consider the case where n is even. If n is even, your r is the same, but your r prime, what will this be, guys? N is an even number, n plus 1 is odd number, divided by 2 will be not be an integer. So what would this be? Come on, guys, think. What do you think this will be? Kampu, you okay? What do you think this will be? N over 2. Okay. So your Q at half will be x right? So this would be x right, and this is equal to, we can simplify this to a half. Oh, sorry, I made a mistake. Shit. Okay. Sorry for my language. Sorry. This should be n over 2, not. This should be n over 2, guys, not n plus 1 over 2. Alright, so this will simplify to okay, so we are done. Okay, guys, so that's the answer for question 7. Any questions, please? Yes.
Does the area of the histogram always equal to 1 of the density?
Should be, yeah, it should be equal to 1. It will be, yeah, it will be equal to 1. Yeah, it should be equal to 1, yes. Yeah. Not.
I'm trying to do like number. Trying to do number 4.
Number 4, we haven't covered it. We can ignore it. We haven't covered number 4 really in the class. We can pretty much ignore it. Yeah.
I'm guessing that
We didn't really cover number 4, so we don't need to worry about it. I will not examine you. Okay.
my summer exams Friday. Yeah. Well, the reason why. I think people here don't
Alright guys, see you tomorrow. You guys going for lunch now?
Yes.
Sit down.
I know there's this like cheap buffet place. Oh yeah, where do you go to church?
I go to, okay, the church that I go to, you know what I'm saying?
No.
You know Lemon Shore?
Oh, yeah.
Yeah, I go to around Lemon Shore. But, there's an event happening at the council square that I'm taking part of.
I mean, what has me preach
I'm not preaching, I just have to talk and stuff.
Yeah, you maybe
But you're not Catholic.
Yeah, I know, but it's like, it's not,
It's like more of the Christian groups.
yeah.
It's not
necessarily like Catholic.
So it's more of like a broad Christian.
Yeah, okay, most of the guys there are Catholic, but I guess it's supposed to be. They're trying for it. They wanted to.
I've been to like the Catholic Society like one time. So they check what is it? It's about. It's cheap.
Isn't it free?
No. Like technically, like you have to do it.
You don't have to. Of course, I would like it if you did, but you don't have
No,
to.
I do it. Like it's disrespect. It's kind of bad.
They just go there and eat free food. But
Yeah,
not
it's
give
bad.
anything.
It's bad.
I'm not giving anything back.
It's bad. They really like trash people. So there's like a.
I don't know if other like misuse that room to use the company. I don't know if other Christian groups use it just it's a convenient location actually. It's extremely convenient. It's really defined behind it.
It's in the center.
It's in the center, so it's a very convenient location. So a bunch of like religious groups actually end up using the temple.
Yeah.
You guys okay? You going for lunch or what?